Had some technical difficulties there, but we're back. So I'm going to show you how to solve this problem. Let's see here. Actually, let me go press it. There we go. Okay, so a compound has an empirical formula of C2H5 and its molar mass is 58 grams. So remember that for step one, too thick. Hold on. For step one, what did you have to do? So you first had to find the empirical mass. So you have a compound that has 2 carbons and 5 hydrogens. So what is the mass? Well, you have to look at the periodic table, and you have 2 carbons with a mass of 12 grams, and I'm rounding here the mass. And then you have 5 hydrogens with a mass of 1 gram. And again, I'm rounding the mass. So that gives me a mass of 29 grams. Okay, so that's step one. For step two, you have to calculate how many times does it go into the molar mass. So for step two, you have the molar mass here given. So that's 58 grams. And you calculated the empirical mass right here. So you divide 58 grams by 29 grams, and that gives you 2. So for step 3, you now have to multiply the empirical formula by that number. So you take the number 2 that you just calculated, and you multiply that back to the empirical formula that they gave you, which is C2H5. So 2 multiplied by 2 carbons gives you 4, and 2 multiplied by 5 hydrogens gives you 10. So then that means that your molecular formula is C4H10, and you can circle that. So I'm going to erase this, but you'll be able to go back to the video if you need to see how these steps are done once again. Okay, so here is the answer. There it is. Okay, and let's continue. So finding the empirical formula for percent mass. So this question is asking you to find what is the empirical formula of a compound that is 7.7% hydrogen and 92.3% carbon. So there's a couple of steps that you need to follow. The first thing you have to do is pretend that the percent is grams. Then determine the number of moles, and then determine the lowest whole number ratio by division. So these are 3 steps. That's my puppy right there barking. So let's go back one step at a time. So first you have to pretend that these numbers that they give you here are in grams. So 7.7 grams of hydrogen and 92.3 grams of carbon. Now you're going to determine the number of moles. So remember that the way that this was done is taking the 7.7 grams of hydrogen and calculating the number of moles. So remember, you have to look in the periodic table. 1 gram of hydrogen is equal to 1 mole of hydrogen. So we learned this back in, not sure what unit, but we learned this back second quarter. So grams cancel out, and you're left with 7.7 moles of hydrogen. So that's this result right here. And then you have to calculate how many moles are in 92.3% of carbon. So the way you do that, once again, is make sure that you convert 92.3% to grams, and this is carbon. And remember, I'm using dimensional analysis here. So I look at my periodic table, and 12 grams of carbon is equivalent to 1 mole of carbon. Okay, this is coming back, this dimensional analysis. Grams cancels out. 92.3 divided by 12 gives me 7.7 moles of carbon. So that was my second step, to convert from grams to moles. Okay. So now I need to go to my third step, which is to determine the lowest whole number ratio by division. So if I have the same here, 7.7 moles of hydrogen and 7.7 moles of carbon, then if I divide 7.7 by 7.7, I get a ratio of 1 to 1. So then that means that the empirical formula is going to have the same whole number ratio of 1 to 1. So then my empirical formula is just going to be CH. Okay? And that's the answer to this problem. So let's try another one now. So for number 8 is asking you to find the empirical formula of a compound that is 20% hydrogen and 80% carbon. So again, here are the 4 steps. Pretend percent is grams. Determine the number of moles, and then determine the lowest whole number ratio, and then write the empirical formula. So here is the answer, but I'm going to work out the problem for you guys right now. So the first thing you have to do is pretend that percent is grams. So you started out with, you started out with 20% of hydrogen and 80% of carbon. So you're going to pretend that those are grams first. And then you're going to determine the number of moles. So again, remember how that was done. If you started out with 20 grams of hydrogen and you are converting from grams to mole, you look in the periodic table, and 1 gram of hydrogen is equal to 1 mole of hydrogen. Grams cancel out, and you're left with 20 moles of hydrogen. And that's what you see here. Okay? And then for your 80% of carbon, you're going to convert that to 80 grams of carbon. So the way that this was done is you take your 80 grams of carbon, you go in the periodic table, you find the molar mass of carbon, which is 12 grams, and that is equivalent to 1 mole of carbon. Okay? Grams cancel out, and 80 divided by 12 is 6.67 moles of carbon. So that's where I got this answer. Okay, so now I've converted to moles. So let me erase this. What do you do next? So what's the third step? And the third step is to determine the lowest whole number ratio by division. So I take my 20 moles of hydrogen and I divide it by the lowest number, which is 6.67. So 20 divided by 6.67 is 3. And then I take my 6.67 moles of carbon and I divide it by the lowest number, which is 6.67, and that is equivalent to 1. So this is the ratio. You're going to have 3 hydrogens for 1 carbon. So 3 hydrogens for 1 carbon. So that is what's going to give you your formula, your empirical formula, which is CH3. So that's where I got the answer to that problem right there. Okay? And there, again, is the answer. All right. All right, let's continue then. A quick review of formulas. Do you guys remember your polyatomic ions? Well, you should remember your polyatomic ions. So a quick review here of your polyatomic ions. Oh, no. So, co, po, and NH4 is our little off to the side ion. So how did we remember the polyatomic ions? First, starting with the charge, negative charge, negative charge, -2, -2, -3, positive. And then hydroxide, no subscript, nitrite, subscript of 3, sulfate, subscript of 4, carbonate, subscript of 3, and phosphate, subscript of 4. So you alternate the 3, 4, 3, 4. Okay, so these are polyatomic ions. So sodium, remember that sodium is Na plus, and phosphate is right here, PO4 -3. So what happens, let me make this thinner. So what happens when you have Na plus and PO4 -3? So what happens with the charges? The charges do what? The charges crisscross, right? So do you remember how to write that formula? Na3, you bring down this charge down here, and then PO4, you leave it as is because this is a +1. It technically comes down here, right? But you don't include it because it's a value of 1. All right. So what about sodium phosphide? Now phosphide is just phosphorus. So if you look in your periodic table, sodium is an alkali metal, charge of +1. Phosphorus has a charge of -3. Okay, because that's just phosphorus. So then you crisscross here, and this is Na3P. Okay, that's it. What about magnesium nitrate? Magnesium has a charge of +2. Nitrate is right here. Nitrate is just NO3 negative. So again, you can crisscross the charges. The 1 comes here, so it's just Mg. And then NO3, you got to put this in parentheses, and you write down the subscript 2, like a little submarine, remember? Now, again, you have to put this in parentheses because you don't want this to say 32. You're saying that there's 2 nitrates and 1 magnesium. And finally, magnesium nitride. Nitride is just nitrogen, and nitrogen is in group 15 of your periodic table. So magnesium, again, has a charge of +2, and nitrogen has a charge of -3. So you're going to crisscross those charges, and you're going to get Mg subscript 3, nitrogen subscript 2. Okay. So how'd you do? Did you remember your polyatomic ions? I hope so. Okay, let me clear this out. And let's go back to showing you the answers, and there they are once again. Okay. I'm going to do a review, probably not now, probably after spring break, on predicting products, the type of reactions, how to write it in a word equation, a skeleton equation, and then learning how to balance. Okay. All right, everyone. I hope you guys are having a great day. I'll see you later.